Hello everyone, please let me know in the chats if everything seems fine, the audio, the video, everything. So how are you, first of all? So this is the second lecture that we are going to discuss uh, about the Ascii codes. In the last stream we have discussed about what is an Ascii code, what's the use of it, and how we can convert an Ascii code into its hexadecimal value. Okay, a character means capital A stand for something 65, capital small a stand for something 97. Okay, this is how we have converted all those characters into their specific ASCII codes. But as we know, computer understand binary, so how we can convert that thing into binary, that's something we are going to discuss in today's lecture. Okay, so as I've told you, please give me a yes if everything seems fine in the chats, and at any point of time if you are having any doubt, any difficulty, do let me know. Okay, so let's wait for 1 more minute, and after that we'll start the session. Okay, so till then let me present my screen with you. Okay. And this time, as I have told you earlier as well, in this program, in this particular path we are going to write the code. Okay, so let me open the ideally. Okay, and here I'm creating a new file, and in this file I am going to tell you how you can convert a number into its binary. Okay, so to give you a basic understanding how binary works. Okay, so for every number, like if I'm displaying 1, okay, so I can define 1 with 1 in binary. Okay, if I am representing 0, I can represent it as 0. But if someone is writing 2, how I can represent 2 in binary, because I am having just a combination 0 and 1. So in that case, what I will do, I will use the combination of zeros and ones. Okay, like for 2 the binary is 1 0. Okay, for 3 the binary is 1 1. Okay, I'll tell you how the whole process works. Okay, for that purpose I am just giving you a couple of examples. Can we zoom a little bit in? Okay, so for 4 it would be 1 0 0. This is how it works. Okay, and how it is happening, it is happening in this particular way. Okay, let me add a couple of more examples so that would be easier for you to understand what is actually happening. 1 0 1, and the 6 is equals to 1 1 0, and 7 is equals to 1 1 1, and the list goes on. If I'm talking about 8, so 8 will look something like 1 0 0 0. Here we will add one more thing into it. Okay, so till here, why this is the particular combination, like wherever in your computer, in my computer, 7 denotes the binary of 1 1 1. Why so? So the funda is, you can treat it like this place is 2 to the power 0. Okay, this denotes by the power of 2. Okay, power of 2. This place is okay, it is starting from here, from the right. This place denotes the power of 2 to the power of 0. This place denote the power 2 to the power of 1. This place denotes 2 to the power of 2. So on, like if I'm talking about the binary of 1 1 1 1 1. Okay, so this is having 5 places. So this place is having 2 to the power of 0. This having 2 to the power of 1. This having 2 to the power of 2. 2 to the power of 3, and 2 to the power of 4. This is how it goes. Okay, but as we are talking about just 3 places, as the number goes up, the computation will also, we will have more number of places. Okay, in this case. Now let's solve the equation, how it is happening, why 1 1 1 only. Okay, so if I'm talking about 7, so this 2 to the power means 2 to the power 2 plus 2 to the power 1 plus 2 to the power 0. Okay, what is uh if I'm dividing 7, okay, in terms of this equation, so what is 2 to the power 2? 2 to the power 2 is 4. What is 2 to the power 1? 2 to the power 1 is 2. What is 2 to the power 0? 2 to the power 0 is 1. So 4 plus 2 plus 1 will give you 7. Okay, that is why, so wherever 1 is there, we will add that power, that place. Okay, so this is why this is giving you a 7, because 2 to the power of, if I am talking about this, so 0th place 1, first place 1, second place 1, means we will take the power of 0 plus power of 1 plus power of 2. Same case if I'm taking the power of 2 to the power of 1 1, if I'm taking the number 6. So what is 6? Let's reverse the process. So 6 is the combination of 4 plus 2, if I'm talking about the terms of power of 2. Okay, 4 plus 2, and this will give you 6. So what is 4? 4 is 2 to the power of 2, right? And this 2 is 2 to the power of 1. Okay, so this place and this place is 1 and this place is 0, because if I'm taking 2 to the power 0 as well, then what will happen? I will have plus 1 as well, which is not something that I want. Okay, that is why 2 to the power 2 plus 2 to the power 1 will give you a 6. That is why it is 1 1 0, right? Not 1 1 1. 1 1 1 will give you 7. Similarly, if I'm talking about 1 0 1. So similarly, if I'm talking about 1 0 1, what does 1 0 1 means? 1 0 1 means 2 to the power 0, means here I'm having 1 at this particular place. Okay, 1 at this particular place means this place is going to be counted. 2 to the power 0 will be counted. It means it is 1. 2 to the power 1, at this place I am having 0, means I will not count this. So this is 0. 2 to the power second place, 2 to the power 2 is 4. This will be counted. So 4 plus 0 plus 1 will give you what? 5. Okay, so that is why 101 is the binary of 5. Okay, so you can take as many examples as you want, but the main funda is wherever you are having the place satisfied in terms of 2 to the power, that will be taken. Wherever it is not feasible, we will not take it. Okay, let's take a bigger example this time. Let's take let's suppose 12. Okay, so what is 12? 12 is nothing but, if I'm talking about the power of 2, it is 8 plus 4. That's it. Okay, 8 plus 4. 8, what is 8? 8 is 2 to the power 3. Means we will take 2 to the power 3 third place and 2 to the power 2 second place. We will not take first place and 0th place. Okay, so if I'm talking about third place and fourth place, so what would be the binary look like? It would look like 1 1 0 0. Okay, because the fourth place, third place and fourth place is 0. Third place should be there, which will give you 2 to the power 3 4. 2 to the power 4 will give you 8. So 8 plus 4 is 1 1 0 0. That's how we add up the values, right? 8, if I'm talking about 8, so binary of 8 would be 1 0 0 0. It will add one place into it, because it's all about the combinations that we are following. Okay, and similarly if I'm adding 9, so binary of 9 will be 1 0 0 1. Binary of 10 would be 1 0 1 0. Okay, binary of 11 would be 1 0 1 1. That's how it goes. Okay, till 12 we can add 12 1 1 1 1 0 0. Okay, 13 we can add 13. Yes, definitely 13 we can add. 1 1 0 1. 14 can we add? Definitely we can add 14 as well. I am just going to show you the boundary condition. 15, can we add 15? Yes, 15 we can add. 1 1. Can we add 16? 16 we cannot add because all the combination till fourth place is gone. So what we need to add? We need to add one more place into it, and what that place would be? That place would be 1 0 0 0 0. So that, what is 15? 16. 16 is 2 to the power of 0 1 2 3 4. 2 to the power 4 is 16. Okay, so as you are proceeding further, the more and more number of places will be added. That is why when we were discussing about ASCII codes, okay, so why ASCII codes are 127? Okay, if I'm talking about the ASCII codes, so here actually we are having the advanced version of it where we are having 255. Okay, but we are having 127 as well in the basic. Okay, let me show the character one. Okay, so here if I'm displaying you the character ones, so it is from 0 to 127. Why 0 to 127? Because what is the ASCII code of 127? It would be of 7 places. Like here we are having 5, there we are having 7 to 8 places would be there in 128. Okay, so what we are going to do now, this time we are going to discuss about how we can automate the process. Write a code which will do this thing for you, right? All you need to do is just write the logic which will convert this particular number to binary, right? This is the code that we are going to write. Okay, and how we are going to do that? Let's do this. Okay, so what I need to do, first of all, I need to define a number, and let me define the number as 5. Okay, we know the binary of 5. What's the binary of 5? Let me comment them as well, so that it would be easier for you to analyze like what is actually happening, if my code is actually working or not. Okay, so n is 5. What I want as an output? 1 0 1. Okay, and how I am finding it? So first of all, what I will do, I will divide the number by 2. Okay, and I will check if that number which I am dividing will give you the remainder is equals to 0 or not. If it is giving you a remainder of 0, then in that case what will happen? In that case we need to write 0. If the remainder is 0, we will print 0. Okay, and else what we will print? Will print 1. Okay, that's the main funda, right? If it is fully divisible by it, we will write 0 as we will write 1. Okay, so let's do one thing. Let me save it on the desktop itself, with a name. Let's suppose binary. Save it and run it, and it is giving you 1, because if I'm dividing 5 by 1, it will be divisible. Okay, now I want to know about the whole binary, so I will keep on dividing it until and unless this process n is not equals to 0. So while n is not equals to 0, what I will do, I will do this, and at the end I will divide n by 2 and double divide by 2. So if I'm saving it and running it, what is the output? The output is 1 0 1. Okay, we are getting the output. Let's change it to 6 and see what is the binary of 6. So it is 0 1 1. Okay, the binary of 6 is 0 1 1, but we are getting 1 1 0. We can reverse it. Okay, let's check for 8. Okay, so if we are checking the binary for 8 and running it, so the binary is 0 0 0 1. Okay, so it should be 1 0 0 0. So let's do it. let's create a string as a string I am adding, and every time I'm encountering whatever I'm encountering, I'm adding it in that string itself. Okay, how it will help me? At the end I will write x plus equals to this particular string, and once everything is done I will print the string itself. Okay, let me save it. If I'm executing it, 0001 is something I'm getting, but I need to reverse it. Okay, because every time you are doing it you will get the answer in the reverse manner. So what I need to do, let's reverse it. So how to reverse it? This is the simple function of reversing it. This is how we can reverse a string. Okay, 1000, that's the answer. So what I'll do, I will write n here, and with this particular column I will write, okay, this is the answer. So if I'm running it, okay, actually I have mentioned ms. So if I'm saving it and running it, so what I'm getting, the binary of, here I have mentioned 0 because here the value of n is changing. So either I can copy the value of n or I can print n on the top only. Okay, so here what I'm doing, printing n, and here I'm writing end is equals to, separator would be none. Okay, and here I can add whatever I want to. So if I'm saving it and running it, so here 8 denotes the binary 1000. Okay, makes sense. That is the answer as well. So let's do one thing, let's change the binary of 8 to, let's suppose 12, and let's see the answer. So the binary of 12 is 1100. You can match it from here. Okay, similarly you can find the binary of any number of your choice, right? Now the trick question is, okay, now I know how to convert a number to its binary. Okay, I know it. So what should we should do now? Okay, once we know how to convert a decimal into binary, now we'll use the same chart. Okay, because earlier we have discussed how we can convert a character to its Ascii value. For example, what does a means? A means Ascii code 65. Okay, and if I'm converting the 65 into binary, what I will get, if I'm writing 65 and running it, what I'm getting, 1000001. That's the binary of 65. Okay, now this is what I have written. So if let's suppose I want to integrate both of the things, so what I am doing so far, I am yesterday we have discussed how we can convert an Ascii code to its decimal. Now we have discussed how we can convert our decimal. Decimal is nothing but the numbers that we are writing from 0 to n. Okay, today we have discussed how we can convert this decimal to binary. Okay, now what we are going to do, we are going to discuss about how we can directly convert ASCII code into binary. Okay, for example, if we are talking about character A, so that's something we have discussed yesterday as well. ORD is a function which will help you to give you the ASCII code of any character of your choice. If I'm writing capital A, saving it and running it, basically, okay, so A stand for 65 as I've told you know earlier as well, and let me, instead of printing n, let's take a copy of it, or here you can also mention A because we are talking about A. So if I'm running it, so here no A in computer will look something like this, 1000001, right? Similarly, if I am defining any number like P, let's suppose, save it, run it, how it will look? It will look something like this, but here it is just denoting A because I mentioned A here. Okay, this is the main difference, like how the whole process works in the computers. Whenever you are writing anything, to the computers it means something else, but just for the sake of representation so that we can see what is happening, this is how it went. Okay, so this is how we can convert hexadecimal into a decimal into binary. Okay, and basically Ascii code into binary. Now the question is, let's suppose if you are writing something like Ashish, how the computer will understand it, or how the computer actually perceives what is actually happening in this. So let me write the code for that. Okay, so this is, let's suppose, a name that we are having. Okay, and what we will do, we'll take that name one by one, and so basically let me write it in this manner. I'm pressing a tab here. Okay, and here what I'm doing, I'm writing for character, each character in name. I'm taking each character, okay, finding it at sky value, putting it here, and after that taking the same character, writing its binary, and after that I'm doing it. So what it will display you, what should it display you? If I'm running it, what I'm getting what computer understands whenever you are executing this, you are writing this name. Okay, from here you can also write with Ashish, with this character you can also write if I'm mentioning it in this manner, it can also be done. Okay, character I'm writing them, I'm mentioning n, and after that I'm mentioning the output. So what you are getting, a whose ASCII value is 65 and binary is this is what computer understands. Okay, from here as well we are having some of the complications that can happen. Okay, means in some of the characters the length can be shorter, in some of the characters the length can be larger, like 7 bits and 8 bits. You might have heard this term, bits and bytes. Okay, so here we can see 1 2 3 4 5 6 7, we are having 7 here. Okay, but if let's suppose I'm writing Ashish underscore Jangra and saving it and running it. Okay, so here you can see for the space we are having 1 2 3 4 5 6 only. The length of space is 6, the length of a is 7, all of them are having character length 7, but only space is having 6 characters. So what we can do in that particular case, for that purpose you are using byte based architecture. Byte based architecture means we are having a 6-bit architecture, every character that we are having so far. Okay, like if I am running this output, so some of them are having 6 size, some of them are having 7 size, so we will standardize it into one character length which is 8. Okay, every character will have 8 lengths into it. If there is something where the length is lesser than that, we will append zeros in the beginning. Okay, so basically it will look something like this. So let me write the code for that as well. So let me add f is equals to, because this is the final character, I will take the reversed string. Okay, I'll find the length of it. Okay, and whichever length it is having, if it is having, let's suppose 7 length or 8 length, I will subtract 8 from it. This will tell you how many zeros I need to append. Okay, I'll multiply with the stars. What it will do, you will understand it, but it will do. Okay, and here I'm writing it with this. So if I'm saving it and running it, so this will tell you how many stars. Here I have added star, but eventually I will add zeros. This will tell you how many zeros I need to append in the beginning so that you will get the exact result. Okay, here it is having 7 length, I need to add 1 star or 0. Here I am having 6, I need to add 2 zeros. Okay, so this is something I am telling you. Here you can see here I need to add 1 0, but it should not be at the end, it should be in the beginning itself. So this is something I will add in the beginning, and after that I will add the whole reversed string. Okay, and this is the final output that we will get at the end. If I'm saving it, running it, now every character is having the same length 8. Okay, that's why it is a 8-bit architecture. Okay, we are having 8 bits, every character denotes with 8 bits. Okay, even if it's a space, you can concatenate all of them as well. Okay, that can also be done, like I'm creating a final string, and whatever we are printing so far, I'm writing fin plus equals to f. Okay, and at the end I'm printing fin. So if I am writing Ashish Jangra, this is what computer understands. This is how we have encoded it. We can decode it as well, but that is something we are going to discuss in the next lecture. Okay, so I'm hoping you are clear with the concept, like what we are doing so far and how you can analyze this thing, how the bits and bytes of computer works, how you can convert from ASCII to binary, binary to decimal, and so on. Okay, so let me summarize whatever we have done so far. So first of all, we have discussed about what is binary, how binary works, how we can convert decimal to binary. Okay, and earlier we have discussed yesterday about ASCII to decimal, how we can do that, and decimal to binary. Today we have discussed how we can convert directly decimal to binary. We have written the code for it, which is this one. Okay, then what we are doing, we are automating the process, like we are writing a string here, and that string should be automatically converted into its binary. First of all, it will convert character wise binary, like A stand for this, S stand for this, then H, then I, then S, and then H, then space, then J and GRA. And if we are concatenating all of them, like 0 1, 5 times 0 1, till here it is A. Then after, next 8 character for S, next 8 character for H, next 8 character for I, and so on. Okay, so this is how the whole structure works. If you are still having any doubt, please let me know in the chats or the comments, and otherwise I'll see you in the next session, where we are going to discuss a little bit about how we can convert it back when we are having this particular string that we are having, a long string where which is the encoded format of Ashish Jangra, Ashish space Jangra. Same thing we are going to discuss, but in the reverse manner. If we are having a such encoded format, zeros and ones, binary, how we can encode it and see what is actually written in this, right? So I'm hoping you have enjoyed the session, and if you are still having any doubt, as I told you, you can ask us in the discussion, and make sure to give it a like, subscribe us, so that we can, it will encourage us to make more such informative content for you. And yeah, I'll see you in the next one.